All right, what we're going to do now is get into some more of the basics behind pre-algebra, so we can be more prepared for Algebra 2. Before we were working with adding and subtracting fractions. Now we're going to get into multiplying and dividing fractions. And you have to understand there's a huge difference between adding and multiplying. So as I said before, adding and subtracting are kind of the same thing. So I'm just going to call it adding. And whenever I just say adding, consider it's also subtracting. And whenever I say multiplying, consider it's also meaning dividing. So adding and subtracting are the same thing. Multiplying and dividing are treated the same way. And now we have a difference. Remember with adding, we were talking about you can only add the things that are the same. Okay, so we can only add and subtract things that are the same. Multiplying and dividing doesn't follow that rule. You can multiply and divide whatever you want. Okay, so that's a huge difference. You can multiply and divide whatever you want, but when you're adding and subtracting, you can only add or subtract the same types of things. So the rules for these two things are way, way different. And when it comes to fractions, this plays out a little differently. So when it comes to fractions, when we have adding and subtracting, remember we need a common denominator. And when we're multiplying, we don't. No common denominator needed. And that is a huge vocabulary piece that will be helpful for basically your math future. So again, when we're adding and subtracting fractions, common denominator. If we're multiplying, remember those two big rules are all different things. So we don't need a common denominator for multiplying. And so the rules for fractions are very simple when it comes to multiplying. So the fraction rule, basically the fraction note, is you can multiply the numerators over the denominators. And that's it. Right? You multiply the numerators and then you multiply the denominators. And what I call that, I use bad vocabulary. I call it top times top and bottom times bottom. So I use bad vocabulary for multiplying, but as long as it helps students to see the difference between the two, I really don't care. So as long as you understand, this is way different than what we're doing for adding. So we use this first example. And I use this first example because it's just fun to look at. And by fun, I mean confusing. Students have a hard time even reading this, let alone working with it. And so the more important thing to do with this first problem is making sure you're reading it correctly. And when you read this out loud, you're reading 3/8 times -2/5. All right, so the reading of the problem is going to be so important. A lot of students will say, is that minus or is that times? And you have to see the difference with the symbols in the parentheses. And so we can clearly see that for this first problem, we are multiplying two fractions. And so how we handle the multiplication of two fractions, very, very simple. We multiply the numerators and we multiply the denominators. So in the numerators, we're saying 3 times -2. And then in the denominator, we're saying 8 times 5. And it's that simple. Okay, so we have 3 times -2 at the top, which is going to give us -6. And then 8 times 5 at the bottom, which is going to give us 40. So that is the basics of multiplying fractions. But now we get into a trickier thing. We get into simplifying fractions now. We have to simplify our fractions. And so how in the world can we simplify -6 over 40? We have to think, is there a number that can divide into both 6 and 40? And of course the answer is yes. They're both even numbers, so both can be divided by 2. And we always simplify our fractions. Okay, so in Algebra 2, we have to get comfortable with simplifying fractions. So we have actually -3 in the numerator and 20 in the denominator, and that is how we can simplify fractions. So that is how we multiply fractions, but I'm going to show you another way. So I'm going to set the same problem up a different way. We have 3/8 times negative 2/5. There is a trick called cross-canceling. And the way cross-canceling works is that you look for the giant 1. There's a 1 in here somewhere. And remember what the number 1 looks like. The number 1 is any number over itself. Okay, that's the number 1. Any number divided by itself is going to be equal to 1. And so whenever you have any number divided by itself, it cancels and leaves you with 1. And so when we look at our multiplication setup, we can look for a giant 1. Now we have a 3 on the top, a 2 on the top, an 8 on the bottom, a 5 on the bottom. And if you know anything about divisibility rules, you can see that there could be a giant 1 with a 2 over a 2 on the top and a 2 in the bottom. And you're thinking, well, where could there possibly be a 2 in the denominator? Inside the 8. So if you can notice, again, it's all about knowing your divisibility rules. If you notice, 8 happens to be 4 times 2, right? So if 8 is 4 times 2, there's the 2 that's inside the 8. Now we have a 2 in the denominator, and we have a 2 in the numerator, and it's our giant 1. Okay, so we can cancel out that giant 1. A 2 in the top, a 2 in the bottom, they cancel because it's a giant 1, and what we're left with is actually 3 over 4, and then times negative 1 over 5. We can cancel that big giant 1. That's called cross-canceling. Cross-canceling. And now we can multiply numerators, and we can multiply denominators. And so we have the same thing that we did when we were simplifying from multiplying straight across. So either way, you can do it. Now, if you don't understand what just happened here, that's okay. Go back to doing this. Just make sure you remember to simplify your fractions. Okay. So that's how we can work out the first problem. Now, what about the second one? The second one has a few little intricacies in there because I am not saying times anywhere. I'm not saying times anywhere. I'm actually saying the word divided by. So when you read this out loud, you're saying divided by. So what is helpful to understand is what division is. Division is actually multiplication of the inverse. So that's a neat vocabulary. Division is multiplication of the inverse. And that is so helpful to know. So division is multiplication of the inverse. That's just vocab piece. How do most of us know this vocabulary? We know this vocabulary from a shortcut that we probably have heard in the past. And the shortcut is called keep, change, flip. And keep, change, flip only applies to division because this is the definition of division, the multiplication of the inverse. So when we're looking at negative 3/5 divided by 11, what we're actually looking at is negative 3/5 times the inverse of 11. Okay, so when we're looking at division, it's actually the multiplication of the inverse, or what we know as keep, change, flip. Okay, so how does this work? Well, we keep, the first fraction the same, which is negative 3/5. We change division to multiplication. Okay, so we change division to multiplication, and then we flip the second number, or take the inverse. So we flip the second number. Now, how in the world do we flip an 11? We have to know a thing. And the thing we have to know is that 11 is actually a fraction over 1. And if you know that 11 is a fraction over 1, when you flip it, or take the inverse of it, you will end up with 1 over 11. And so we flip the second number. So when we're dividing, we're actually taking the multiplication of the inverse, or what you may have heard before, keep, change, flip. And so we have this particular problem. We set it up using multiplication, and now guess what? We are right back to where we were for the first problem, where we simply multiply the numerators and multiply the denominators, and this is how we can work with multiplication and division of fractions. So that's it.